Section 8.2a is about monomials again. This time we're dealing with quotients or division. I want to examine this fraction and see if we can come up with a new property based on this. 4 to the 5th power, that means 4 times itself 5 times. So I'm going to rewrite it this way. Divided by 4 to the 3rd, which I will rewrite this way. Now based on what you know about fractions, these 4's will cancel. So will these and these, leaving me 4 times 4, which is 4 squared. So if we look at the original fraction and we look at what it ends up becoming, we might get a sense that this suggests a certain property that when you take the exponents that are being divided, you need to subtract them. And that is called the quotient of powers. And here's what the rule looks like in general. When you have two bases that are the same and you divide them, you subtract the exponents and you leave the base just the way it is. That's the quotient of powers rule. Here are some examples using the quotient of powers rule. In this case we're dividing a to the 5th and a, and I'm going to separate that into a separate fraction, and I'll also do the same for the b's. According to the quotient of powers rule, when we divide bases that are the same, we subtract the exponents. So this becomes an a to the 5 minus 1. Don't forget, when there is no exponent there, we assume there's a 1. So this is an a to the 4th. And over here we have b to the 8th minus 3 would be b to the 5th. This example, same thing, x to the 7th over x to the 6th and y to the 12th over y cubed. Dividing, when we divide bases that are the same, we subtract the exponents. So x, y to the 9th. Here we're going to examine another fraction to develop a property. We have a fraction 2 to the 5th to the 3rd power. Well, what does that mean? That means multiply 2 to the 5th times itself 3 times. So what we end up doing is we end up taking the number 2 and multiplying it by itself 3 times. That means 2 to the 3rd power. Same thing with the 5. Multiply 3 times. So what this seems to indicate is that when we have a fraction that's inside of parentheses and there's an exponent on the outside, that exponent has to go into the exponent of every term inside. And that's what this property is all about. It's called the power of a quotient. And this property says that when you have an exponent on the outside of a fraction, you have to bring that exponent in to both the top and the bottom, and it becomes an exponent on both. That's the power of a quotient rule. Here's an example that we see, an exponent on the outside, which means the exponent has to be applied to everything. It's got to be applied to the 2, to the exponent that's already there, and down to this number. So let's see how that works. 2 to the 4th power. When we take a power like this 2 to another power, that's a power of a power rule, we have to multiply those exponents, and then the 4 also has to be down here. So simplifying another step, 2 to the 4th power is 16, p to the 8th, and 3 to the 4th power is 81. Our next example incorporates the power of a quotient rule and also a quotient of powers rule that we also learned. So let's do that. This 3 has to apply to everything. So 4 cubed c to the 3 times 3, because you multiply exponents when you take a power to another power. d to the 2 times 3, that's power of a power there. 5 to the 3rd, e to the 4 times 3, and f to the 7 times 3. Notice how the 3 on the outside applies to everything inside. And now we're going to simplify. 4 cubed is 64, c to the 9th, d to the 6th, over 125, e to the 12th, f to the 21st. Nothing else cancels, none of these letters are the same, numbers can't reduce, so we're done.